Hey guys, this is Ben Osborne with Thermo Scientific, and in this video we're going to look at all the options in the administration menu in Proteome Discoverer 2.0. And as in earlier iterations of Proteome Discoverer, the easiest way to get the administration menu is just to click on the administration tab at the top of the screen and just click on anything underneath that tab. And this will open up the administration menu. And here at the top we see that we have selected the job queue, and on the right we see the job queue, and this will be every file that has been submitted for processing, that has finished recently or is currently processing through Proteome Discoverer, submitted directly through Discoverer or through the Proteome Discoverer daemon. We see some high-level details, the name of the file, when it was submitted, the study, the data source, and then a short description, what have you put in the description box. Look down here at the bottom where we have some normal consensus and processing methods. If we open these up, we get some more details. We can see here in this processing method, we started off with a spectrum selector, followed by sequenced HT, then percolator, and then we quantified all the ions with the reporter's ion quantifier. And then the consensus from that, we took the MSF file from that processing method. The PSNs were extracted, validated into peptides. We filtered the peptides with these filters into proteins. The proteins were scored, then grouped, and then annotated. So we see a whole workflow and all the details and when each event happened. A really useful thing here is if you have some workflows that fail, say in the middle of the night, you can go in and see when they failed. It's not uncommon for a lot of IT security systems require periodic reboots, and a lot of the times we'll find that, say at 3 a.m., workflow will shut down because, unbeknownst to you, your computer went through a security update and killed Proteome Discoverer during that processing. So this is one way to find that. If you have other problems during your processing scheme, you can find those problems here and kind of diagnose where we're having issues. The next thing here are FASTA files. Clicking on this will bring in the list of FASTA files that have been successfully imported into Proteome Discoverer. All databases need to be brought in here in order to be used. To pull one from your hard drive, click Add, and then we navigate around to where we've got our FASTA files. On this, I've got mine on my storage drive, data backup, and then I could find my FASTA files. Oh, here they are. And once you find one, let's find a nice one that I haven't imported before. Oh, Helicobacter. I'll open that. By hitting open, this will pop this over into the job queue. Refresh the job queue and see where that is. If we're looking at bacterial genomes, we'll have things imported in, and typically just a few seconds. Human database may take a few minutes. This is all dependent on the speed of your computer and the speed of your hard drives. If you're bringing in, say, the entire Uniprot SwissProt database, that may take upwards of an hour, but it's all dependent on your hardware, how long this will take. See, we brought an entire bacterial genome collection from Uniprot, about 15 seconds. So this probably includes all of the sequenced variants and substrains of Helicobacter. If it was a single strain, it would take a few seconds. New feature in Proteome Discoverer 2.0 is the ability to download databases directly from the Protein Center. If you have the taxonomy ID, you can choose what format to download that in, SwissProt, Tremble, Ensemble, and so on, and it will download this database. If you brought in databases this way, you could go here and check for updates from Protein Center. It will look at the databases that you have present and will update the annotations if there are new annotations available. You won't have to go filtering around, searching on the internet to find databases that you can parse and put into Proteome Discoverer. You can go and simply download them and then update them. Next in the FASTA files, once we have those, we have to index those, and that's where we generate the theoretical MS1 and masses and the MS-MS spectra that we will use for our searching. So every FASTA file will have to be indexed in order to be searched. If you want to index one on your own, we simply go, we add a FASTA file that we've brought in. We add, and we pull down a FASTA file that has been successfully imported. Say, put in this Clostridium perfringens, and then we put in the static modifications. We don't have to worry about dynamic modifications. Those don't actually change the indexes, but here it'll say, okay, you know what, this is all I-track labeled at K's and the N-terminus. I-track 8 on the N-terminus, right? Then you click OK, and then that will get queued up, and that'll take a few minutes for a bacterial database. It may take a few tens of minutes if you're doing a much larger database, a big eukaryotic genome. It all depends on the processing power of the instrument that you're processing on. So this is something that we can do here, but really we don't ever have to do it. The first thing that happens when you submit a processing workflow is the Proteome Discoverer will take a look and see if an existing index is present that matches what you have in your processing workflow. If it isn't, it'll go ahead and create one. This is mostly useful for just checking to see if there are any problems with your indexes, if you use the correct enzyme and that kind of thing. In general, you really won't ever have to use this menu unless something is wrong. The next tab here is spectral libraries. This is a very advanced topic that I'm going to go into in later videos where I would just talk about spectral library processing. And but if we had spectral libraries, this is simply where we would import them. Click the add button and just bring them in the same way we did a FASTA database. But again, look for the videos on spectral library searching in Proteome Discoverer 2.0. The next set of features here under chemical modifications, and clicking on this brings in our set of modifications that are inside of Proteome Discoverer 2.0. This is the entire Unimod database as of the point that Proteome Discoverer 2.0 was written. If it is a couple years later after the launch and there are some modifications that you know people have discovered that you have not been able to find in this list, you can always just quickly hit the import button, overwrite existing, and it will copy in all of the modifications in the Unimod database as of the date at which you hit that button. So we can just update those, and now we have an updated database. Alternatively, we can add a new modification. Just click the Add Modification button, name the modification, give it an abbreviation, give it a delta mass, which is the total shift that we would expect over our normal amino acid. So then you put in a delta mass. Never hurts to have that in there. I'm just randomly striking keys, by the way. And you can add in the substitution, which is what you're adding to the amino acid. And if it's taking something off, say you have to pull off nitrogen to make that modification, then you can put that in. Realistically, for the search engine, it really doesn't care that those are there. Those are primarily for your notes. Now, I'm not quite done yet. I need to click somewhere else on this Unimod database. So this is imported, and now I need to tell it what amino acids this exists on. So say my fake mod here will modify asparagines and N-termini. And just add that here. Hit the apply button, and now it is searchable through any of the fully ported nodes in Proteome Discoverer. This includes Sequest and MS Amanda. If we're talking about the mascot search, you'll have to change those on the computer where mascot is housed. But for MS Amanda and Sequest, here we are, these modifications are present. If you know that you're never going to look at formulation, it's something that you do not care to see every time you pull up modifications in sequest, you can simply unclick formulation, hit apply, and now you don't have to see those anymore. The next thing on the list are cleavage reagents. We have all the normal ones here, trypsin and staph protease and cyanogen bromide, chymotrypsin. These are all of our normal enzymes. If you've discovered a new protease and that's what you want to use, you put in a name and you put in a cleavage site. Say your new protease cleaves at alanines, but it doesn't if that alanine is near a lysine. And then you just need to tell Proteome Discover how specific is that enzyme. Does it cleave all the time, semi when it's N-C-termine? We can select one of these or all of these. Let's say here in this enzyme, full and semi specific cleavage. Hit apply, and now this is an enzyme protease that you can use in any of your searches. Now, next thing here are annotation aspects. So the annotation node is a way of bringing extra data about the proteins that you've discovered into your reports. Here we have control over what aspects show up in our final report. And here, say I'm not really interested in the molecular function or in the biological process. For this study, I really just care where these proteins are localized in the cell. What cellular component are they from? So I just click, I deactivate these two, hit apply, and now that's the only data that will show up when I use the annotation node from here on out. Now, I can also add a new aspect and say there are a group of proteins out there that I know are of interest to me. I specifically want those flagged so that this is that it just pops out. The data that I'm interested in comes out, and say give it a name. We'll call it important stuff. And then we can go ahead and make an annotation group. Once we do that, we'll get these little boxes. Say we've got a new annotation group. We'll say group 1. I'll choose a color because that's how the annotation node shows things in these nice little colored blocks. I'll say, look, group 1, I want it to be labeled hot pink. So when I see things, and I can look up things through gene ontology or through protein families, Entrez PFAMs, and I want to click on that and say, okay, important stuff to me is anything that shows an HSP20 domain. And click on that, add it over. Oh, it's got an SH2 domain, that's important too. Right? So I add this in, got the color, I say save. So this is my important stuff. Now, if I want to use this for the set of data that I'm currently processing, I leave that active. If I don't, later on, okay, this was important stuff for this study, simply drop that out, hit apply, and now I'm back to what I had labeled as important earlier and my cellular components. Right? So the next thing here are quantification methods. This has all the quan methods that were loaded with the default version and when you installed Proteome Discover 2.0 and any additional quan methods that you've added since. We can pick a quan method. So let's look at the Silac 2-plex. We'll just highlight this. And then I can go directly in and I can edit that. Say, I know I'm always going to want to see my light over heavy. I can change this. I can look at the different labels. My light is always going to be no labels. If I wanted to add in a new label and say, okay, like I need a medium label, this is where we would do that. And here's where I would make modifications. I would pull in that label. I currently don't have a good medium label. Well, we'll just choose this +8 anyway, and we'll put it on case. Okay, so this is where we would modify methods. If I wanted to make a completely new quant method, say you've invented a new labeling method, but you want to process the data, but it's something like SciLac, would want to add a new method. And there's a couple different ways I want to do that. This is my chemical label. We can create one from defaults. The easiest way I think is if it's like a normal quant method, just you just made something better. Well, we just clone this from the existing method. So say again, yeah, it was kind of like SciLac. So again, it's kind of like SciLac 3-plex. I'll create that and then go in and change my modifications, presuming that I've added those modifications in the chemical modifications tab and made those active. Now I can pull those up and then modify this method and have a brand new quant method on the labels that I invented. Further options in the administration tab. The next thing we find are licenses. We can see when our Proteome Discoverer will expire and the various features. We look at expired licenses. We can see other licenses of Proteome Discoverer that may be on the computer that have passed and have expired. Here I don't have any, so there's not much here except for the fact that my demo key is only good for another 40 days or so. Below that, here's where we configure things. So a lot of times people want to change things. What's going on behind the workflow, and this is where you would get in here and take a look. We'll ignore this because this will not be available in the commercial release. But further on, if we look at mascot, this is where we would configure our mascot server. What you would need here is put in your mascot address, say mascot.com or whatever your address is through your network to your mascot server. Then you would put in, this is going to error probably. Nope, yeah, that's going to let me take that. This is where you put your username, and if you've got a password to your mascot server, if you've got those features enabled on the mascot server, you'll have to put these in or you won't be able to reach it. This is how we would configure that. Under the mascot node, we can set our significance threshold. So if we're at high significance, is it a 1% false discovery rate essentially, and our middle significance at 0.05. For past mascot protein scoring, it automatically defaults to mud pit, or we can set that true or false. So we have some features here. For the other nodes, for MS Amanda, we can look at how many, decide how many spectra we look at once, what percentage of the CPU is currently engaged. So if you're using your computer and you still want to have some capabilities to process everything through Proteome Discover, but you still need some data. This is your desktop. You want to do some word processing. Maybe you don't want to have 100% of your resources devoted to MS Amanda. This is where you can trim that down. Most of these further nodes, you can do this exact same thing. We can set how many cores, how many resources do we devote to the search in case we want to use this computer for something else as well. We can set our thresholds for confidence, both for strict and relaxed, and fragment ion combinations. For our MSF files, how we're filtering those from the PSM level, this is where we would control those. MS PepSearch is one of the spectral library search algorithms, and again, this is where we would set the configuration for that. I have installed the Bionic and Preview nodes. We'd have control over those as well. For Protein Center, this is the because we're reaching out of the network to reach the Protein Center through the internet, we would need to have this address in here, and if we do have the capabilities, we have a Protein Center license to upload data. This is where you would put the URL in your username and password. For PTMRS, here's where we set our parameters here. We would want to set those accordingly. These are good defaults for all of these different nodes, but if you know a little more than I do about the PTMRS node, you want to change your scoring around based on what you saw in the publication, this is where you would do that. For Sequest, we have the Sequest HT node. This is where we would change our cross-core factors. If you go back to late 90s when everyone was changing their cross-core thresholds around to get better IDs. This is where we would make those changes. You can also set how many parallel tasks you want at once. Again, say I'm on a 16 core PC right now, and if I wanted to say, okay, I only want to use 12 cores for Sequest search at once, that way I've still got 4 cores in the background that I can continue to work on Excel spreadsheet or possibly film tutorial videos. This is where I would say, okay, don't use all of my resources at once. And again, I can change all my cross cores. These are really, really good X-core cutoffs. The defaults are more than appropriate for most things, but there may be times when you would want to adjust those. We can also adjust our peptide relevance factor for scoring our proteins, and make adjustments to the Discoverer daemon, and determine where we put our FASTA files and our FASTA indexes. But all I wanted to cover here was what is available in the administration menu, and so that is all for this video.